Good afternoon, and thank you for joining. My name is Julian Hall, Product Manager for Digital Services here at Danfoss. Today's supermarkets are fully loaded with connected, technical and complex assets. If you just look at the refrigeration system itself, we have compressors and condensers, evaporators, sensors, valves. If you factor also into that, we have HVAC systems and lighting systems. All of these systems have the potential for providing a significant amount of data points. But in order to provide in order to eliminate the risk of data overload, what I'm going to do during this session is actually introduce you to 5 particular use cases whereby using the Alsense food retail platform that we can collect and take these data points and turn them into value. When we're developing our Alsense platform, we're considering many different stakeholders. We have the stakeholders which are from a managed services organization. We have those which are third-party service providers. We also have the food retail professionals themselves. So what sort of features and functions are they looking for? And then finally, we also have our technicians. So those that visit the stores to do the commissioning and then later on the optimization of those assets. So we're keen to capture all of these requirements in our roadmap to make sure that as we go forward, we're providing the best possible technical platform that we can for value creation for all of these stakeholders. So let me start by looking at the first use case. So in a store, typically the starting point for optimization here can be triggered via an alarm. So we'll have a look at our alarm monitoring and management capability within our platform. So our first customer really is our internal customer. So this is the managed services facilities that we offer here at Danfoss. So we actually have 2 24/7 monitoring centers, one in the US and one in South Africa, which is providing a full range of alarm capturing and processing and resolution services to either contractors or to the end user. So in order to handle the processing of this information, we have an Alsense alarm management solution. So in our call centers last year, we captured and processed over 1.6 million alarms per month. So when you think of that amount of volume, then we need to be very precise in how we capture it and how we process it. So this application is doing exactly that. So we have all of our agents sat in front of the Alsense alarm monitoring system. So the alarms are coming in from the store, and then they are assigned to an agent. So depending on the complexity of the alarm, we make sure that it's assigned to the correct agent who has the right skill set to address the issue. As that agent then is processing the alarm, it may require some escalation to somebody else more technical in the team. So again, we build the full audit trail of exactly what has happened from the moment we receive the alarm to the moment that we resolve the alarm. That could also require work orders being produced for a contractor to go to site, or it could simply require a communication to the retailer or the store, informing them of the nature of the alarm and what do they need to do within the store that can help to address it. So that's the first part of the alarm process. So now if we move into the second stage, so again, we're still looking at the alarm thread. So alarm for food retailers. They're very keen on seeing the transparency of these alarms. So how many did they have? Where are they? Is there some commonality in those alarms? And is there something that the retailers can do themselves to make sure that these stores are being optimized? So here I introduce you to the Alsense alarm portal. So this is a dashboard that we make available to the retailers. And as you can see, very much a executive dashboard concept, whereby at the top of the screen here, we're identifying some of the highlights or headlines of the alarms that we've been processing during the given period. So how many of these are considered to be critical alarms, which require immediate attention? what generally is the alarm count compared to previous periods, and also some intelligence around, out of all of the alarms we've received, how many of these are repeat alarms. Also over on the right-hand side here, we're very keen to make sure that we're not just pushing data at the end user, that we're actually turning this into some key focus areas. So retailers are clearly very busy in their day-to-day work. So what we're doing here is identifying what are the 6 key focus areas that that retailer needs to look at immediately if they're going to help address some of the key problems that we're finding in the stores that the alarms are telling us. This dashboard can then have drill down capabilities. So if the end user wants to go and see some more details about the alarm, they can then drill down. So here is the example of the 2 critical alarms we saw on the previous screen. So what is the nature of those? And again, there's additional drill down capability to find out a little bit more detail about the reason for these alarms. And finally, from a visualization point of view, perhaps you want to see the spread of the alarms on a geographic perspective. So here we have a map, and you can clearly see here that we have some pins on the map, which is helping to identify if there's any sort of correlation between these alarms. For example, on a geographic map, you may find that there is a difference in ambient temperature from one region to the next. That could absolutely be a cause for high temperature alarms within a store. So again, that sort of breakdown where you can see it visually helps you to identify the root cause of certainly the most critical alarms. So if you move on also within the food retailer, so again, we're still looking at alarm data. So we've processed some of the alarms in a monitoring center. We've provided transparency now into alarm performance for the end user. But also now what I'm doing is providing a different dimension to alarms. So I'm not talking about alarm volumes anymore. What this dashboard is doing is it's helping to monetize these alarms. So maybe somebody within the organization, rather than just looking at alarms which they may consider to be noise, by monetizing them, it certainly gets a different level of attention. So on this dashboard, what I'm showing is 4 different categories of risk, financial risk. First one being food loss potential. Then we have refrigerant loss, service costs, and also energy costs. So just using one example of food loss, for example, what we're calculating here is based on the volume of alarms that we're receiving, which are specific to high temperature alarms. What percentage of those will typically result in a food loss claim? Then we can monetize the food loss claim based on the size of the store. So by computing both of those together, what it can give us is it'll give us a monetary figure. So in this case, if we mismanage the handling of these alarms, then potentially what is the value of financial risk associated with doing that for each of the 4 categories. So the top half is showing me the story for the particular chain of stores that perhaps I'm responsible for. And then the second half of the screen here at the bottom is then comparing that to some benchmark data. So how are your stores performing compared to the Danfoss install base of connected stores within food retail for each of these categories? So it just adds a very different perspective in terms of whether you're actually doing well or whether certainly there is a real chance of a high monetary risk associated with mismanagement of these alarms. So there is the first use case. Let me take you into another example now, whereby we're providing some tools for third-party service providers. So these are service providers, not Danfoss, whereby we can provide some tools to these stakeholders to then provide value-added services to their end-user customers. And we're going to have a look at temperature data. And what I'm going to start by looking at here is what we call temperature quality. So if I give you the scenario here that we have a service provider, it could be a contractor company, who is working with an end user that has been assigned a certain number of stores. And their responsibility is to make sure that they provide the best possible temperature quality for that retailer. And what this dashboard here, first of all, is showing me, it's giving me the list of the stores that this service provider is responsible for. It is showing me the number of connected assets that we have within the store. And then, as you can see, we have a color-coded system here. So wherever we're seeing white, this is where the temperature generally in that store is running within a normal range. As we move to the right-hand side, we're seeing some stores perhaps where the temperature is more on the high side. Some of the cabinets are too warm. And on the left-hand side, where there could be an issue perhaps with a higher energy consumption because we might be overcooling some of the cabinets. Generally, this picture looks fine. We have a very good level of normal temperature ranges. But if we sort it slightly differently, so now if we sort it on one of the higher temperatures, you can see very quickly now that the store at the top, store 252 in this case, it has 98 connected assets, and here that would be the store that if I wanted to spend some time looking into how I can improve the temperature quality across the estate, that would be the first store where I would spend some of my time. So if I drill down into this store, now it's the same picture, but I've just expanded it to now show me the performance for each of these individual assets. So these typically will be refrigerated cabinets in the store. They could also be cold rooms within a store. And by sorting it as we did previously, you can very quickly see now that in terms of my priority as a service provider, without even needing to go to the store, I can find out which one of the assets within the store perhaps do I need to pay attention to, and even at some point maybe send a contractor to the store to actually address the problem. We have some additional diagnostic tools within the platform. So I could also go into here, I could select any of the assets, and then I could trend the temperatures. So this will very quickly highlight for me whether generally we have a temperature problem within that asset. Are we consistently running it perhaps over the required thresholds? Or as we can see here, we have a couple of anomalies perhaps, which will be a little bit easier for me to actually go and identify what the root cause of that problem was. And again, for speed here, I've just selected one asset, but again, I could go and show exactly the same picture for all of the 98 assets that I have within the store. So again, if we carry on with the stakeholder of the third-party service provider, so logically, when you see a temperature quality map, like the ones that we've just looked at, the first thing that you would need to go and look at is to analyze the set points within these assets. So exactly the same as we did with temperature, I'm now looking at the stores that I'm responsible for, and I'm just seeing a map here of how are the set points configured within the stores and also then within those assets. So in this case, it's sorted. It's showing me which of the stores actually has the most deviations for set points within the stores. So the top one here is obviously the one that we need to have a look at, because it's telling me that for 63% of the time range that we have in this particular dashboard, the set points are within the required thresholds. 26% of the time, however, they are outside of the high range, and then 11% they're actually in the low range. So that would certainly be the first priority for me, would be to go and investigate the set points in that particular store. So here we are, as we did with the temperature quality now, I'm now looking at all of the assets within the store. I'm having a look at exactly the deviations in these set points, whether they're on the high or the low range. Although we can't see it here, but in the system I could then click on my little icon in the middle here. What that would do for me, it would show me that between the date ranges, how many times those set points have been changed. So again, a very good indicator to help you identify if this is something which is happening on a regular basis, or has this perhaps been a one-off change, a contractor has been to store, made a change, and it's actually been running at the wrong set point for 2 or 3 months. So again, a very, very useful tool remotely, whereby the service provider can make sure that all of the settings within that store is exactly where it needs to be, as though they just commissioned that store. Okay, let's have a look now at a different stakeholder. So based on again the temperature data points that we're collecting from the stores, what value creation can we add here for the food retailer? And what specifically we're going to look at is the use case around food safety compliance. Clearly, a number one priority for a retailer is making sure that they have the highest possible food safety compliance across all of the refrigerated cabinets in their stores. This is exactly what this dashboard is doing. So for a particular store, so if I'm the store manager in this instance, I can see a full list of all of the refrigerated assets and cold rooms within my facility. And then I've got an average of the temperature on an hourly basis for the last 24-hour period. So this is a color-coded dashboard, so it's very easy for me to take a look and clearly identify which of these assets, for example, perhaps are running too cold, or in a worst case scenario regarding food safety is clearly these ones which are pink or red, which is showing me whether these are too warm. We can also use a report like this for showing defrost cycles. So also from an energy efficiency point of view, very useful to see what are the schedules for the defrosts, because perhaps you might be over defrosting some of these cabinets, therefore obviously not maintaining the ideal temperature regarding food safety at any moment in time. Again, let's use the same data but for a different purpose. So here many regions have to ensure that they have regulatory compliance around what we call HVACR temperature monitoring. So one of the services Danfoss is providing is the fact that we're collecting all of this data from the stores, coming via our system managers installed in the store, uploading that into the Alsense Cloud, and then on a daily basis we can automate the process whereby every single one of the connected stores is actually receiving a PDF report from us, which is showing them exactly what their temperatures were for each of the 24 hours for the previous day. That can then be stored locally and is available at the point where perhaps it needs to be audited by the local authorities to make sure that they are adhering to their food safety obligations. One of the key things that we're finding when we're visiting food retailers, and that is in terms of collecting temperature data. It's never a problem for collecting data when these are, if you like, permanent cabinets, or the ones that are piped into the store, onto the network, and then we're collecting data. But we're finding up to 10% of the cabinets in a store could be what we call plug-in cabinets or standalone cabinets. So these could be cabinets which are provided by a promotional company. It could be a soft drinks manufacturer. It could be an ice cream manufacturer. So they have these cabinets near the checkout used for promotional items. So what we can do here using our Prosa technology is we can install the appropriate device. So in this case, this is a Prosa Solo device. So it's a wireless telemetry device that we can install somewhere on the cabinet, and then that is transmitting the temperature data from that cabinet into the Alsense Cloud. And as you've just seen previously, we can then capture and report that data in exactly the same way as if it was one of the permanent cabinets connected to the network. If you want to find out more about the Prosa telemetry devices, then join the commercial refrigeration session, which is part of Cooling United Live, and that will give you an introduction into more details about the technology and also the apps that are available with some of those tools. As we move on, let's have a look at our fourth use case for value creation. And in this case, energy efficiency. Now, typically we will find that energy efficiency projects are either ran directly by the end user themselves, or alternatively they may be getting support from a third-party service provider. It could be an energy consultancy company, for example, that is working with the retailer. But certainly in Danfoss and in the Alsense food retail platform, we're very keen to make sure that we're providing both the visualization of the energy data, but also some of the tools to make sure that energy is being managed appropriately and identifying opportunities for these savings. Now, as we know, we can't manage what we can't measure. And Danfoss aren't in the business of producing energy meters. So in this case, we work together with one of our partners, which is Centrica Business Solutions, who then provide an array of energy sensors for us that we then install into our supermarkets. So now let me introduce Henry Stephenson, who is having an interview with one of our contacts within Centrica Business Solutions.
Thank you, Julian. And with me now I have Mr. Daniel King from Centrica Business Solutions. He's Director of Strategic Partnerships. So hi, Daniel, and welcome.
Hello, Henry. Thanks for having me.
Good. Daniel, could you tell us a little about Centrica Business Solutions and the partnerships with Danfoss?
Yeah, sure. So Centrica Business Solutions is a division of Centrica PLC. It's an energy services and technology company providing thousands of organizations globally with the means to optimize and become self-sufficient in the way they manage their energy. The capabilities Centrica Business Solutions has built up over the last few years through acquisitions of leading and cutting-edge technology companies. One of them was a company called Panoramic Power, which developed a wireless self-powered sensor technology to easily capture energy data from many assets within a facility. And it's through this technology that we have started a partnership with Danfoss, who are a leading provider in food retail and providing IoT solutions to food retailers. And we have decided, obviously, that Danfoss is in a great position to take the sensor technology across their many thousands of customers worldwide to bring this technology to that market.
Mm-hmm. Okay, thanks. So how do you see the Centrica portfolio of power meters adding value to the food retail segment?
Yeah, so specifically to food retailers, there are a number of different applications here. I think firstly, by the monitoring of energy consumption at machine level, it allows food retailers to understand the top energy consuming assets within their stores. So decisions can be made to prioritize retrofit projects and maintenance activities. Second, it gives insight about good and bad practices on the way that employees operate the stores, and also enables remote oversight over how the automation systems are performing. And thirdly, there are big potential savings not only on the energy consumption, but also on the demand side. With circuit level monitoring, it's possible to detect the exact moment and loads that can help stores participate in demand response programs, which can contribute significantly to revenue generation from these programs.
Okay, thank you. So a strong partner and a product program that really complements the Alsense portfolio, I can hear. So thank you very much for joining, for taking your time, Daniel, and back to Julian in the studio. Thank you.
So thank you, Henry. So now what I will do, I'll show you a little bit about the sensors that we're actually installing in the supermarkets. So typically here you can see that we clearly we have some main metering data, but there's also many other opportunities for sub-metering in these stores. So if I just give you a quick introduction here into some of the technology that we're using. So this is what we call our PAN 10 sensor. So as you can see, a very small sensor, very easy to install. So these are clip-on wireless sensors. This particular one here can monitor current up to 63 amps, so typically small assets. Then if I take what we call the PAN 12, so this one is up to 225 amps. And again, there's a series of different sensors depending on what the size of the asset is that we actually want to monitor. We also have a PAN 42. And the PAN 42 here is equivalent to a main meter. So we can get more data points out of this particular meter. So whether it's a single load, dual load, or a three-phase load, for example, then we can take those data points, also power factor information. All of this can be captured from the PAN 42. And then where it ends up is we have this bridge device. So then the bridge device is installed in the store. It is capturing data from these sensors every 10 seconds, stores it in the bridge, and then from a wireless, either via Wi-Fi, Ethernet, or even cellular, it will transmit the data from the bridge into the cloud, and then we can start making use of it within the Alsense Food Retail portal. So there's the enabling devices, if you like. So now as we move on, let's start having a look at what are we doing with this information. So again, very conscious we don't want to overload with information. So we're aggregating the data, the energy data that we're receiving from these devices. And we're providing a nice high-level dashboard. So very similar to what we saw earlier when we looked at the alarm dashboard. So we're just calling out some of the main headlines across the top banner here. So how many of our stores, in this case 23 of them, are currently performing above a baseline measurement? So perhaps these are the stores that require our immediate attention. Generally, how is the consumption across the portfolio compared to a previous period? And also putting some monetary value onto that. What is this looking like in terms of euro for what our consumption is? Are our costs higher or are costs lower than a previously defined period? Then moving into the main dashboard, we're comparing against different sites across the estate. Also from a geographic point of view, are there particular sites geographically which are performing badly with respect to energy performance? So again, that's where we need to focus our attention. And what some of these devices are certainly doing is enabling us now to improve our understanding of what the energy profile is, both across the estate, but also across the individual stores. So how much of our consumption is to do with refrigeration? How much of that refrigeration is coming from a compressor pack? How much are from cabinets? And also how much is HVAC and lighting? So by installing these simple devices, we're then getting that transparency of data that we can start using. Right now we have, we're focusing on the visualization of this data. As we move forward into 2021, we're also building some additional tools into our energy platform. And these tools will enable us to produce very accurate energy models for stores. So this way we're using different statistical techniques, different variables such as the size of the store, ambient temperatures, all of which will then enable us to normalize, so very accurately we can compare in a relative format what is one store doing in terms of their energy performance compared to another. So that activity is on our roadmap for 2021. And then also then taking that further, we can use that to predict what is our energy performance expected to be going forward as some of these underlying variables change. Okay, let's look at the final use case. So this is a high-level introduction into what else are we working on here within the Alsense Food Retail platform. And as I mentioned, we're certainly keen to make sure we have something in the roadmap which is satisfying the immediate needs of all of the different stakeholders we have in our ecosystem. First one of these being, let's extend this thinking around energy. So again, we are working with stores which perhaps are at the next level. They've already optimized the existing assets and plant regarding energy efficiency. And now they've moved into, for example, renewables. So what we're doing is we're creating some dashboards. This is simply a prototype, so there is some gaps right now. But what these dashboards will do for us is it will be able to analyze for us what is the energy mix in a store. So what are they consuming themselves? Perhaps what are they generating themselves through solar PV panels, for example. Also using energy storage battery capability. How much of this are they able to store and then reuse? And also, what is the impact if there is a heat recovery installation, for example, in the supermarket? So all of that is certainly what we're expecting to produce, bring to the market during 2021. We have some prototypes ongoing right now, which are certainly demonstrating to us that this is a very high value add for some of the more advanced retailers that we're working with. And then also just to finish off, again, for more of the technical service providers, how is the core plant working? So what is the compressor pack doing? Clearly one of the main areas for energy optimization. So what we're doing here is we're creating a dashboard. And in this case, we have, first of all, on the left-hand side here, a type of a quadrant system. So ideally what you want to do is you want to make sure that the compressor packs across your estate, wherever possible, are actually operating here within the neutral zone. So here we're correlating suction pressure against compressor capacity. And either on a store level or an estate level, at some point we may find that some of these quadrants are turning from blue to red, in which case we're potentially having a problem here. There could be a maintenance issue ongoing. And then on the right-hand side also then the ability to drill down to a store level and actually start seeing how are these compressors performing in terms of run times, etc. Finally, what we're working on now, and this is a recommendation engine. So the idea being that based on all of this data we're collecting and all of our knowledge inside of Danfoss in how these assets operate, we're very keen to make sure that we're producing predictive and preventative maintenance tools. So what we will be having here is a recommendation engine. So based on the data we collect, we can then share with a service provider or even an end user specifically what are the 2 or 3 things that they need to do now to make sure that they're optimizing their plant. So there's just 2 examples of some of the roadmap activities we're working on, and we would expect to be able to introduce those to you during 2021. Finally, it just leaves me to thank you for spending the time to join this session. Hopefully you found it interesting. There will be a Q&A immediately after this session. So if you have any questions based on what you've seen or generally about where we're going with the Alsense food retail platform, then I'll be available and very happy to answer any questions you may have. Thank you.